Hello all, hope all of you are fine. Today I will discuss about the continuous session of JFET. In the previous class I have discussed that in case of JFET, if Vg is equal to 0, then what will be the characteristics and the construction. Today I will discuss the construction and characteristics of JFET in case of VGS less than 0. Okay. So those students who have not yet show the previous video or have not seen the previous video, please go that video and can see that. But I am revising the previous part again shortly. In the previous video, I have discussed about the construction and characteristics of JFET in case of VGS equal to 0. And in case of VGS equal to 0, you can see that source will be grounded. Okay. And the construction and the characteristics I have told, and I am repeating again that in case of VGS equal to 0, the source will be grounded. So there will be no potential difference. So here VGG equal to 0. Okay. So in that case, what will be happen? The depletion region. First of all, the in for of PN junction depletion region will occur, and if the VDD, the current occurring for drain to source, the current is flowing, that this VDD, if we connect this VDD with drain and source with giving the higher potential in drain and lower potential in the source, so with increasing the VDD, the current will increase. With the increasing current, the depletion region will also increase. And how the depletion region is increasing this time, I have told in the previous video. Please see that. I hope you can understand. Okay. So today, in the same topic, I will discuss that if Pg is less than 0, then what will happen. Okay. So see here. Here, in the previous case, what I have told, VGS equal to 0. So in that case, source was grounded, right? But in this case, VGS is less than 0. That means VGS have some potential difference. Because VGS less than 0, so we can think that, or we can tell that the G or the gate terminal will have the negative or the 0 voltage or the lower potential voltage, and the source have the higher potential. Okay. That can give an example that if the potential difference between gate and source will be -1 volt, then we can tell that in the gate terminal there will be -1 volt, and in the gate terminal there will be 0 volt, and in the source terminal there will be -1 volt, because here source is upper potential or higher potential and G is here lower potential. Okay. Now, what we have seen in the previous day's class, that if VGS equal to 0, so that what means that here no potential difference, here source is grounded, and with the help of this VDD, with the help of his VDD, the current is flowing from drain to source, and with increasing the current, the depletion region is also increasing is this type, because there is a higher potential and there is a lower potential, so their reverse biasing will be high and then reverse biasing will be low, so that this type of depletion layer we can see here. But if VGS is connected with a battery like this and there will be a potential difference, so what can happen? let's suppose that here is no VDD. Okay, let us not consider that there is any VDD. Let us consider only VGS or VGG is here. Okay, and we are giving the potential let 2 volt. Okay, so basically here will be, we get VGS equal to minus 2 volt, because here G is lower and S is higher. So here G will be 0 and S will be 2, so potential difference will be minus 2 volt. Okay, so now here we already have distributed the voltage VGS. So what will happen? The depletion region, in the previous case, the depletion region already used to be created because of PN junction. But after giving the VGS voltage, the depletion region will occurring same as we discussed in the previous class, that with the help of VDD how depletion region is increased in the same case, but here not for the reason of VDD, because we are not considering VDD anymore, we are considering only VGS. For VGS here depletion region is increasing, and the same type on the same case, how that here you can see that here G is 0 potential and here N is in higher potential. Okay, in the same reason here will be the depletion region will be very high, and the depletion region here also depletion region will create, but not much than the higher. Okay, here depletion region will create like this type. So what can we see, that without giving the VDD, with the help of VGS, we can create this depletion region which resists the current ID, to flow with through the N channel, right? In this figure you can see that, that if VGG here will be, if we give any type of voltage and here is no VDD, if we not consider any type of VDD, then what will happen? I am repeating again, then what will happen? With the help of VGG, the depletion region will create in the same matter, in the same reason, because of N is here N is the lower potential and here N is the higher potential, so that the depletion region will create this type. Okay, now without giving the VDD, we can see this. Now if we connect the VDD, then what will happen? If we connect the VDD, then we can see that we have seen about the pinch off voltage, right? In the previous class I have told what is pinch off voltage, in which voltage the current will saturate, that voltage is called pinch off voltage. But in this case the pinch off voltage is come before we giving any VDD. Let us suppose if VGG is minus 2 volt and VDD is 4 volt, then you not have to wait for 4 volt that the pinch off voltage will come. Before 4 volt the pinch off voltage will come, because in the firstly we are already distributing the VGS to this JFET. Already we are distributing this VGS with the voltage minus 2 volts, so that the depletion region will start accordingly without giving the VDD. But after connecting the VDD, when the current will try to pass through the N channel, the current will see that the already depletion region is created, and with the help of VDD the depletion region will also high, but the pinch of voltage will come shortly. Then if the case, in the case of VGS equal to 0, the pinch of voltage, we have seen that the pinch of voltage is come at the 4 voltage or at the 8 voltage, the if VDD accordingly with the measurement of VDD. But in this case, if VDD will be 4 volt, we have not to wait for 4 volt. Before 4 volt we can find the pinch of voltage. I hope you can understand the reason, and the reason will be more clear if you see these drain characteristics. Okay, here you can see that this is the VDS, this is the ID, and this is the VGS. And now see, in the previous class I have told that only for VGS equal to 0 the current will first increase, and up to which time? Pinch of voltage time, and after pinch of voltage the current will saturate. So this is the saturation region and this is the pinch of voltage I have discussed. So in this case, what we can see that this VGS equal to 0, we can see that current will, with the increasing of current, the current will increase, then current will saturate, and very clearly see that there is the pinch of voltage. Okay, now if VGS equal to -1 volt, then what will happen? If VGS equal to -1 volt, that means the pinch of voltage, you can see that the pinch of voltage is come before the VGS equal to 0. That we can find early. We can find early the pinch of voltage than the timing of VGS equal to 0. If VGS equal to -2 volt, then we can found or early that VGS. So with the increasing of the negative voltage of VGS, we can found the pinch of voltage more early, right? So here you can see some regions, right? Now in this region we can call this is the pinch off region. Okay, this is the pinch off region, and this curve you can see that which point we can identify the pinch of voltage that is connected with a curve. You can see that curve, and so that this gray region is called the ohmic region. And can you tell me that why it is called the ohmic region? You can pause the video and can think that. I hope all of you can find the answer. Very simple answer, because we all know the ohmic law that V equal to IR, that the voltage is proportional to the current. So the graph of that will be Y equal to mx time, like a straight line. So in this case we are seeing that this is the straight line case, right? I hope there is some mistakes of giving the points, but you can remind these things that the pinch of voltage is not this will be the pinch of voltage. I hope this will be the pinch of voltage. So here will be the ohmic region we can see. There is the in this region the current is saturated, so obviously this is a saturated region. And the breakdown region, we have told already in previous class that I have told the question up to how much time the working of pinch of voltage will occur. And the infinite time? No, obviously one time will come that when in that voltage current will increase hugely, and that voltage is called breakdown voltage, and this is the breakdown voltage region. In case of VGS less than 0, we also find here breakdown region. Okay, and this is the VP, that means pinch of voltage. So this is today's concept, and we can find the difference between VGS equal to 0 and VGS less than 0. What is the main difference? I hope you can find that if case of VGS equal to 0, the pinch of voltage will come in the manner of VDD. What the value of VDD? So the pinch of voltage will come because there is no interference of VGG, because VGG or VGS equal to 0 here. But in case of VGS less than 0, that means there is some potential difference in VGS. So that what will occur? when we are not connecting VDD, so VGS is already connected there, so VGG with the giving any type of voltage in VGG, a depletion region will occur in the same manner. In the previous case of JFET, we have seen the depletion region will occur, and that will create a resistor, and the current will not pass, current will saturate it, and that voltage is called pinch of voltage, and this pinch of voltage will come very early, as the case of VGS equal to 0. And in that case, if after VGS is distributed, then if you connect the VDD, then you can see that with giving very much low voltage or very slight voltage, you can find the pinch of voltage very early. Okay, this is the main difference here. Now the thing that we missed or skipped the previous class, that is the symbol of JFET for N channel only, obviously. So I have told that there is a trick to remind the symbol of JFET. So here you can see the symbolic expression of for N channel JFET. Here you can see that this is the gate terminal, this is the drain terminal, this is source terminal, and the main thing, that is the arrow which is situating in the gate terminal, and this is inwards. So this is for N channel JFET. Okay, and there is VDS and there is VGS, there is ID and there is IS, that means this is drain current and this is source current. Okay, now the symbolic difference between N channel and P channel JFET. Look carefully. In case of N channel JFET, the arrow is inwards. In case of P channel JFET, the arrow is outwards. Now the question is how to remind. It is happening sometime that in the examination hall or in the Viva examination we are confused sometimes that how we can remind the direction of arrow. So a trick you can apply at that time, that in case of N channel JFET, you know that there is two types of P type material, and in the main the channel will be N channel. Same for the P channel JFET, that is vice versa. That means there will be two N type material and there is P channel. Okay. Now just consider only this type, only this region, consider. Okay, for to remind the trick, only this region consider. Then always remind that the arrow will go from P to N. Always, in any case, arrow will go from P to N. Now in case of N channel JFET, which is P and which is N, if we only consider this region, which is P, which is N, obviously this is P, that the blue region will be P and the pink region is N. So P to N, the arrow is where? The arrow is inside. In case of this region, don't consider this region, only this region. In this case, also in this case, the P to N is inwards, so the arrow is inwards. Same case, the P channel JFET, you can see there it is the blue the blue region is P type and the pink region is N type. So here P to N, that is outward. In this region P to N is outward, so the arrow is outward. So this is the trick to remind the symbolic difference or symbolic expression for N channel and P channel JFET. So with this lecture I will end the topic of JFET. Next day I will discuss about MOSFET, metal oxide semiconductor field effect transistor, one another type of FET. Okay. So I hope all of you can understand this video. If any type of problem occurs, you can write in the comment section below. And if any type of doubt occurs, then you can mail me. I will write in the description what will be my mail. Okay. So all of you stay safe, stay healthy. Okay, bye.